Hi, hello, my name is Naveen, the bearing roll number 24BQ180496 of EC Department B section. And today's my chapter is switching theory on logic design. First, we have to discuss the topics that what we have to learn today and what I have to discuss today. Topics: what is logic gates and types of logic gates, explanation for few logic gates and its applications. First, we have to go with the second slide. A logic gate is a fundamental electronic device in digital circuits that performs a polynomial logic operation, one and more binary inputs to produce a single binary output. These building blocks of digital systems such as computers, smartphones, usually electrical devices, electrical signals, who represent the binary numbers 0 or 1, or make decisions or perform operations based on the specific ruling. The seven logical gates are AND, or not, NAND, nor, XOR, and etc. Each with unique symbols and functions. Let's see unique symbol and their functions in the next slide. Here, this is the NOR gate. This is the first we have to discuss about the AND gate. In AND gate, there are two inputs and we can get as output as Y. Here, two inputs are A and B. There are four possible outcomes in 0, 0, 0, 1, 1, 0, and 1, 1. And output is equal to y is equal to a into b. Is an AND gate 0 0 a and 0 into 0 0 0 into 1 0 1 into 0 1. So the respective outputs are given with the respective inputs. Next gate is an OR gate. The truth table of OR gate we can see there are this is also similar to that here, but this is a sum. Here we are also have two inputs a and b, and it gives a summation, and it gives a summation on the truth table. We have two inputs in A, B, and we have four possible outcomes: 0, 0, 0, 1, 1, 0, and 1, 1. We can see 0 plus 0, sum 0 carries 0, 0, 1, 0, 1, sum 1 carry 0, 1, 0, sum 1 carry 0, 1, 1, sum 0 carry 1. We have to remember the specific, the two inputs are 1 and 1. Binary, then the sum is equal to 0 and carry in the one we can use only for problems. And the third logic that we have to discuss about the not gate. Not gate, the device having that symbol and truth table we have only one put the respective complementary is now respective complementary of the given binary number is known as not gate. If we give 0, we get the complement 1, and if we give 1, then the complement is 0. Next, we have to discuss about the NOR gate. NOR gates also seen completing of the A and B. It gives A into B complement. This NOR gate have two inputs and produces output of Y is equal to A into B or complement. We can see the truth table. There are two inputs. The possible outcomes are 4, 0, 0, 0, 1, 1, 0, 1, 1. So the respective output is Y is equal to first A into B is equal to 0 whole complement. Complement of 0 is 1. And A into B is also A into A into 1 0 complement 1. A into B ಅಂತ 0 complement ಅಂತ 1. Complement. Sorry, here is Y. Sorry, here Y is equal to is a wrong. Nor get Y is equal to A plus B or whole complement. Just we can see with the ball pen. Just Y is equal to Y is equal to A plus B. This is here there is a wrong in symbol. Sorry for the inconvenience. Y is equal to A plus B all got in NOR gate. So we can these output respective outputs. Next, second one is a input NAND gate. This is the correct way to the for the NAND gate. NAND gate there are two inputs A and B and respective case A into B whole complement. In NOR gate it gives A plus B whole complement. But in diagram there is some wrong now that I corrected. Right hand root when the four possible outcomes are 0, 0, 0, 1, 1, 0, and 1, 1. So the respective complement of y is given as 1, 1, 0 into 0, 0. The complement is 1 and 0 into 1 is equal to 0. Complement is 1. So that's the next we have to discuss about the XOR NOT gate. Input XOR NOT gate. This also gives there are the input in the effective diagram as shown the logic gate. There are two inputs and it gives an output AX or not B. So the respective two table there are first output outcomes gives 0 0 1 0 gives 1 1 0 1 1 1 0. These are also equal to 7 etc. And there are two inputs so then give respective outputs. So next we have to go with the input 2 into XOR NOR gate. Here there are also two inputs A, B, and respectively gives output A plus A nor B whole bar, A nor B whole bar for 0, 0 input 0, for 0, 1, 0, it gets 0, for 1, 0, it gets, sorry, for 1, 0, it gets 1, 1, for next slide. The logic gates are fundamental in. So we have discussed the similar logic gates. So there we have general logic gates. The general logic gates are NOR gates, NAND gates, NOR, OR gate, and NAND gate. And universal gates are NAND gate and NOR gate. We can build any circuit by using this. We can build any logic gate by using this universal logic gates. So we have to briefly discuss that logic gates. Logic gates are fundamentals in digital circuits. Logic gates are mainly essential in many electronic devices, smartphones, etc., etc., and laptop. So they have used in many applications in the computers, communication systems, and consumer electronics. In many electronic devices, it makes a great role. Every sensor is makes if we see any sensor that is made up of with logic gates, even our phone sensor is made up of with logic gates. The sensor is depends upon these logic gates only. The process is binary data. Most of the logic gates are also always depends upon the binary numbers 0 and 1 perform arithmetic operations, store information in memory, and control hardware functions. Key applications include microprocessor and memory for binary data processing and storage communication systems for signals encoding, decoding control systems for decision making based on the sensor inputs and the consumer electronics like smartphones and calculations. Simple examples include basic circuits with push button, locks, automatic water match, and safety mode. Yes, we discussed in this section is about the logic gates. So we discussed about in this section is about the logic gates and we discussed about the different logic gates and its applications, etc. We are mainly discussed about the NOR gate, OR gate, NOT gate, NAND gate, NOR gate, and their inputs and outputs, restrictive outputs. And there is sorry for the slide correction of the NOR gate. It gives out in the slide we have y is equal to a into whole bar, but it is not wrong. Y is equal to a plus b whole bar is the right. So we have discussed. So in this section we discuss about the logic gates and etc. So we have discussed about the implications of this. By using this new, there are the NAND gate and OR gate are the universal logic gates. We can build any logic gate by using these universal values. In general, in many companies, Many companies do not have all logic gates. They give you also logic gates and they ask to build, show you how to build that. Logic gates are mainly used in control devices of smartphones, except push button locks. Here we consumer like smartphones and calculators it also used. Simple examples are include basic circuits like push button locks and automatic wasting systems and safety thermostats, etc. Thank you. Thank you.